So in this video, we're going to revisit the car rentals problem that we looked at in the previous video. So if you will remember, we were looking to see whether Thrifty is less expensive than Hertz, and we were given data. We were told that these data both pass normal probability plots and box plots, so the data appear to be approximately normal with no outliers. So we verified that based on the statement in the problem, and we needed to find the differences so that we could test whether mu sub d equals 0 versus mu sub d is less than 0. So this is the scenario, and so I'm going to show you how we can do this problem in the calculator and in StatCrunch. So if I bring in my calculator, first of all, if I go to Stat and Edit, I have already entered the data into List 1 and List 2. So I have the Thrifty data in List 1 and the Hertz data in List 2. So I'm going to put the differences in List 3, and I can do that by highlighting L3 and typing L1, which is the second of the 1 button, minus L2, which is the second of the 2 button. And so that gives me the differences here in List 3. So in other words, if I take Thrifty minus Hertz, then for this first row, Thrifty was $2.82 more expensive than Hertz. That was for the city of Chicago. And then for the second row, Thrifty was $8.10 cheaper there, and that was for the city of Los Angeles, and so on. So we have the differences here in List 3. Now, to use our calculator to conduct this hypothesis test, we're just going to do a simple t-test on this data in List 3. So if I go to Stat and Tests, we're going to do a t-test. Now in this particular case, we actually have data. So I'm going to go to Data. The mean in our null hypothesis is 0. The data are in List 3, so we've got to tell the calculator that the data is in List 3. That's already there on my calculator. And we have to choose the alternative hypothesis, which in this case is less than. So if I say calculate, then I get t, that's the test statistic, t naught equals negative 0.436. Now that is the same value that we got whenever we computed this by hand. It also tells us that the p-value is 0.3364. Now we got 0.3366, so we had a little bit of rounding error that the calculator did not obtain. The calculator's a little more accurate. So anyway, the p-value is 0.3364. That is larger than 0.10, so we do not reject the null hypothesis. Now, we could also do this work in StatCrunch. So looking here in StatCrunch, I have the Thrifty data down this first column, which I've labeled Thrifty, and the Hertz data down this second column, which I've labeled Hertz. So in order to do this test, now again, this is dependent data, so I'm going to go to Stat and T-Stats, and I'm going to go to Paired, because we have paired data. So sample 1, that is the Thrifty data. Sample 2, that is the Hertz data. So again, I'm just putting in the name of the column that has the data. And if I go to my hypothesis test, so H naught is that mu sub d equals 0. The alternative hypothesis, H sub a, as denoted in StatCrunch, will be that mu sub d is less than 0. So if I say compute, StatCrunch gives me the test statistic here, which is negative 0.436. That agrees with both our by hand calculation and our calculation on the calculator. And the p-value 0.3364, which agrees with our calculator calculation. So this is how we can use StatCrunch when we're doing a hypothesis test for paired data, and we're looking for differences in the population means of paired data.